Hey guys, so today we're going to talk about stories, dealing with functions, and being able to look at a graph and be able to make a story, which is really fun. Okay, this is going to be a fun lesson. Okay, so there is two learning goals. One, I can analyze a graph, determining whether the function is increasing or decreasing, and if it's linear or non-linear. So we're going to be able to look at a graph and you're going to tell me where on the graph it's increasing, okay, if it's linear or non-linear. And we talked about linear and non-linear yesterday. And then the fun part of this lesson is goal number 6. I can create a graph that matches a given story. So we're going to talk about both of those today. This lesson, it is kind of hard to do notes with. Okay, so we are going to do it a little differently. I have this wonderful textbook, okay, that the county office provided to us. It is amazing, and I'm going to use that today to teach. I just want your full attention, okay? Don't worry about copying down anything. Just listen to what I am saying, okay? Hope you can see it. So a graph can be used to model the functional relationship between two quantities. The graph may or may not include numbers on axis. Graphs may be linear, non-linear, or both, and may contain sections showing the graph increasing, decreasing, okay, or remaining constant. Okay, so I'm going to draw an example. Okay, so if I have a graph and something looks like this, okay, this part would be increasing because it's going up. This part would be remain constant, and then this part would be decreasing because it's going down. Okay. So here's the first example. A meat thermometer measures the temperature of a chicken roasting in the oven. Okay, the graphs show the changes in temperature as the chicken cooks. Okay, so you can look at this. Is this a linear graph or non-linear? It's non-linear, okay, because of the curve to it. Is it increasing or is it decreasing or remain constant? And yes, it looks like it's increasing and then it kind of levers off right here, okay? Very good. So using the labor graph, we're not going to talk about that. So the graph gives us a general idea that the temperature of chicken rises slowly at first. Okay, so you can look at this part right here. Okay, then it starts to pick up a little more quickly. Okay, until it begins to taper off. Okay, so there's different parts to this graph. Okay, and this graph matches exactly what this is saying. So the second example, the graph shows Naomi's distance from her home during a back ride. She leaves home and rides to her friend's house, visits for a while, and then rides back home. Okay, so we're going to actually map out, we're going to look at this graph and see if we can relate it to what this is saying. So, it is first saying that she leaves home. Okay, so if we're looking at the distance from home, okay, in time, where's the starting part? Where's your right intercept going to be at? Okay, it's going to be at 0 because when she starts off leaving from home, okay, she's at home. She's 0 distance from home. So she's going to start right here. Okay? And she rides to her friend's house. Okay? So she's going to ride. Again, this is the time. Okay? So as she's riding to her friend's house, okay, minutes are clocking by. Okay? So the farther she goes from home, the more time that's passed. Which makes sense, okay? So this part, would that be increasing or decreasing in this graph? Increasing. Is it going to be linear or non-linear? Linear, okay? Because it's a straight line. And then it says she visits for a while. And she probably talked. Okay, she visits for a while. She is not, her distance is not, she's not going farther from home because she's at her friend's house. She's just staying a while. Okay, but as she stays, what happens to the time? The time increases. Okay, but the distance does not. Okay. And then finally, she rides back home. She goes back home, okay? So she's going to go back home and she's going to stop when she gets to y = 0, okay? Because remember, y = 0 represents the distance, okay? When she's at home, she is 0 distance from home, okay? But the time keeps going, okay? So her whole trip was 45 minutes, okay? So this part of the trip would be a constant, okay, not changing. This would be increasing and this would be decreasing in the graph, and it's going to both be linear, each part of it. Okay, so with these graphs you can really look at a graph and pinpoint exactly what the word problem is saying. Okay, so being able to relate back and forth is going to be the main goal of this lesson. And eventually I'm going to give you a graph and you're going to be able to create your own story based on what that graph says. Okay, but you have to pay attention to what, okay, the y-axis is labeled, so this is the distance. Your x-axis is the time. Okay, it's very important that you read these labels, okay, because if you don't, then you really wouldn't be able to make sense of what the graph is saying. Okay. So both graphs shows Naomi riding at a constant rate until she stops and does not travel any further, okay, which is this part, indicated by the horizontal line. Looking at the steepness of the decreasing section of the graph tells us Naomi's return home was at a faster rate than her trip to her friend's house. So if you look, this is more relaxed, okay, this line is steeper. Okay, so it's going to be, she's traveling faster to get back home. Probably because she had a curfew and she wasn't listening and she had to be home right then. Okay, so that's that. These are fun. I really like these. So, number 1, rich graph shows the relationship between the time and temperature as the block of ice is heated. Okay, so I want you to pause this video and I want you to tell me what you think. Which one do you think represents this scenario? Okay, again, I want you to read, this is the time and this represents the temperature. Alright, so let's look at it. The block of ice is heated. Okay, so this is the temperature. This is 0 degrees. And what happens as you go up? The temperature goes up. Okay, so this graph, it represents the starting point of the block of ice being right up here, but to be a block of ice, it has to be freezing. So this doesn't make sense. Remember, your right intercept is your starting point. So this graph is saying the temperature of the ice is starting way above 0. Okay, and then it's freezing up again. It does not make sense at all. So your answer is B, okay? So this is your block of ice, 0 degrees. This is the time that it's heated, okay? And as it is heated, what is happening? As it's heating, as the time goes on, it's getting warmer and warmer and warmer, okay? And it's going to melt. Okay, so it's just using your context clues would really help you with it too. Okay, so number 2. So draw a graph that models the situation. You're listening to music. You turn down the volume to talk to your friend. Okay, and I'm going to highlight each part. Okay, after you finish talking, you put the volume back up where it was. And you continue to listen to music. Make that one orange because we ran out of colors. Right? So if you look at this, you have your time. Okay, you have your time and you have your volume. So when you listen to music, it says we are currently listening to music. Okay, 0 volume will be down here. So if you're listening to music, okay, your volume is already up. So you're not going to start from this point down here, okay? You're going to start from up here. Okay, because that represents the volume. You're not going to be listening to music if you can't hear it. So the volume is going to be up. So it is saying we are listening to some music for a little bit. Doesn't say how long, doesn't matter. Okay, we're just sketching what this graph might look like. And then it says you turn down the volume. So again, this is volume, so I'm going to go down. But at the same time, time is racing away. Okay, and you're going to be talking to a friend. Okay. So when you talk to a friend, you're not going to turn that volume all the way back up where it's at, not when you just turned it down, okay? After you finish talking, you put the volume back up to where it was, okay? So it was up here, so we're going to go back up there. And it says you continue to listen to music, okay? So at that same volume. So your graph might look something like that. This is not the most perfect graph, okay, but it will do. Okay, so again, when you're listening to music, you're not going to start at 0 volume. Okay, you're going to start, your right intercept is your starting point. So when you graph this, you need to pay really close attention to where you're starting at. Okay, because you might not always start at this corner. Sometimes your right intercept might be up here. Okay, and that is perfectly fine. Okay, I hope this is making sense. The more we do, the easier it's going to get. Okay, so this would be the time where I gave you practice problems, but since we're doing it out of this book and I can't really zoom in, we're going to do one problem at a time. So go ahead and pause the video and complete number 1, and when you're done, hit play and I will go over the answers with you. Okay, welcome back. Okay. So it says the graph shows Donovan's hat above the ground floor while riding the elevator as a function of time. If the graph increasing on each of these intervals, check yes and no for each interval. Okay, so this is time and this is hat. So from 0 to 15, so you're going to look from 0, okay, to a 15, which is right here. Is your graph increasing? Okay, no, it is not. Okay, so let's look from 15 to 20. So from here to here, is your graph increasing? Yes. Okay, how high off the ground, okay, was Donovan? At 20 seconds, how high was he? Okay, he was about 15 meters off the ground. Okay, so again, you can still read this, okay, because it has numbers, which is nice. Okay, so from 20 to 40 seconds, okay, am I increasing? Nope. Okay, I'm remaining constant. From 40 to 50 seconds, what am I doing? Increasing. Okay, from 50 to 55, am I increasing? Nope. Okay. So on each of these parts, is it linear or non-linear? Linear. Okay. So for number 2, pause your video and complete this problem for me, and then hit play when you're ready for the answers. Okay, so just a little reminder, linear is straight, non-linear is when you're going to have the little curve. So this wants to know, where is the graph non-linear? Where does it curve at? So I'm going to take this and I'm going to look at this graph, and I am just going to highlight everywhere it's not a straight line. Okay. So now I'm gonna look at these intervals. So this one is from 0 to 1.5, and this one is 4 to 5.5. Okay, so which one of these matches that? And my answer is going to be B. So for this one, again, pause it, try it, and then we'll talk about it. Okay. For 3, your answer is going to be A. Only the dew points. Okay. Okay. So for your homework, you need to pay really close attention, or your practice one, because I am going to make a copy of the page, post the page, and then you're going to write your answers on a piece of paper. And then once you get done with that piece of paper, you're going to click on the assignment on the quiz, and it's just 1, 2, 3, 4. Just put your answer choice there, so that way you can get your answers back quickly. Okay, if you have any questions, or if you're not happy with your score and you want to do it again, let me know and I will give you another chance. Okay, I hope you have a good and a wonderful day. Bye.